Okay, good afternoon. Today's topic, week 001, vector analysis, subject ECE 6201 Electromagnetics 1. I'm your OLC from Engineering Department from AMA Makati, Prof. Trinidad. Okay, we start. Definition. The vector analysis is a branch of mathematics that deals with the quantities that have both magnitude and direction. It has a physical geometric quantities called scalar that can be defined by specifying their magnitude. A vector quantity can be represented graphically by a direct line segment symbolized by an arrow pointing in the direction of the vector. Okay. Vector analysis, a branch of mathematics that deals with quantities and have both magnitude and direction. It has a physical and geometric quantities called scalars that can be defined by specifying their magnitude. Okay, yung vector analysis kasi, isa branch ng mathematics siya na nagdidil siya ng quantities. Meron siyang both magnitude and direction. Then, it has also a physical geometric quantities na tinatawag nating mga scalars. Then, that can be defined by specifying their magnitude. Okay, meron tayong mga example later. For example, a vector quantity can be represented graphically by a direct line segment, then it is symbolized by an arrow pointing in the direction of the vector. Okay, familiar na rin kayo dyan sa vector. Okay, continue. Let's continue. A scalar is the term scalar refers to a quantity whose value may be represented by a single, pwede siyang positive or negative real number pag sinabi natin scalar. Then the x, y, and z we use in a basic algebra are scalar. For example, yun nga, sa Cartesian mode natin in electromagnetics, is meron tayong x and y and z axis. Then it is represented also as algebra are scalar. Then, and the quantities they represent are also scalar, as I said before. If we speak of a body falling a distance, L in a time, T, then temperature also T, at any point in the ball of a soap whose coordinate are x, y, and z, then LT and capital T, x and y, and z are all scalar. Okay, pag sinabi natin scalar kasi is meron siyang mga quantity katulad ng sa time. Ang unit na ginagamit natin sa time is in seconds, that is also a scalar. Then sa temperature is usually kapag mga temperatures naka-degree Celsius, yun yung pinaka-common. Then we have also Kelvin, then degree Fahrenheit. Okay, that is the example also of the scalar. Then in coordinates, also in a scalar, for example, in a Cartesian mode, we have x, y, and z. Then we have also L, yung mga length, time, and period. Then x, y, and z also are all scalar. Okay, another example of a scalar quantities ay yung mga example natin ng mass. Okay, since meron siyang magnitude, mass na unit natin usually is naka-kilograms or grams. That is also example of scalar quantities. Also density, pressure. That is ang unit ng pressure natin is naka-Pascal, but not force. Hindi kasali yung force. Then we have also the volume. For example, is naka-liter. Then we have a volume resistivity and the voltage. Voltage unit is volts. Okay, that's the example for a scalar. Okay, now we discuss now the topic for vectors. Vectors quantity has both magnitude and direction in space. Okay, ang pinagkaiba lang nung sa vector, sa scalar is ito ay meron na siyang pinagsama, combine, have a both magnitude and direction in space. We are concerned with 2 and 3-dimensional spaces only, but vectors may be defined in n-dimensional space in more advanced application. For example, ang example ng vectors, we have the force, velocity. Alam naman natin, ang unit ng velocity is meter per seconds, then acceleration is meter per second squared, or pag sinabi natin vectors is meron siyang magnitude at direction. Katulad ng velocity, meter per seconds. Okay, meron siyang magnitude then and meron siyang direction. Then a straight line from the positive to the negative terminal of a storage battery are example of the vector. For example, meron tayong straight line also. Then it consists of positive 2 going to negative terminal of a storage battery. Example na din yun ng vectors kasi meron din siyang direction and magnitude in space. Okay? Each quantity is characterized by both magnitude and direction. Okay? Katulad ng velocity, meron siyang magnitude. Okay, meter per seconds. Tulad ng ganyan. Then we have also direction. Okay? That is vector. Okay, we have an example for this one. Give 3 example of a scalar quantity and a vector quantity. Okay, yung kanina, yung mga natakil natin, yun na may example. Katulad ng mga weight, mass. Okay, that is example. For example, ito na yung sagot. A scalar is a quantity which has a magnitude only and no direction. Since ang example is scalar lang, pumapasok sa scalar yung mass. As I said before, yung mga kilograms. Temperature is yung mga degree Celsius, tsaka Kelvin, at tsaka yung area. Okay, that is the example for scalar. For example, 12 kilogram, 70 grams, then 4 pounds, and sa temperature naman is negative 8 degree Fahrenheit, then 27 degrees Celsius, and 310 Kelvin. Okay, that is the example for scalar. Okay, next, which of the following are the scalar and vectors? Ito yung example natin. We have entropy, time, acceleration, and force. Okay. Ang common example kasi ng vectors consists of both magnitude and direction. Kaya magiging sagot natin, for example, in the following are scalar and vectors. Entropy is a scalar. Then yung time is a scalar kasi seconds lang siya. That's magnitude lang. Then acceleration is a vector kasi ang SI unit ng acceleration is meter per second squared. Okay. Then sa force is a vector. That's kilogram meter per second squared. Okay, that is the example of force. Okay, sa vector naman, ito yung pumapasok na example ng vectors. That is electric field intensity, velocity, and momentum. Okay, that is the example for vectors. Okay, now, these are the vectors algebra. For example, meron tayong mga equation na ginagamit natin sa electromagnetics. Katulad nito, the addition of vectors follow the parallelogram law. In this figure, for example, show the sum of two vectors. Since meron tayong dalawang vectors, that is A and B, it is easily seen that i-add lang natin siya, A plus B, then equal din siya sa B plus A, or the vector addition obeys the commutative law. Pag sinabi natin commutative law, katulad nito, vector addition also obeys the associative law. For example, to A plus multiply times B plus C, then magiging equal lang siya sa A plus B, then plus C. Okay, lumipat lang siya. Or nagkameron ng associative law. Okay, that is the example for vector algebra addition. Okay, sa vector algebra subtraction naman, the rule for the subtraction of a vector follows easily from that for addition. Ganun lang din, katulad lang din dun sa addition na common. For example, where we may always express A minus B as A plus negative B, then the sign or the direction or the second vector i-reverse. Okay, naging reverse lang siya. A minus B as, then magiging ganito rin siya. A plus B, alam naman natin na positive times negative is magiging negative B rin siya. Kaya equal din lang din yan sa equation na to na A minus B is equal also as A plus negative B. Then the sign or the direction of the second vector is reverse. Naka-reverse lang yung sign. Okay? And this vector is then added to the first by the rule for vector addition. Okay? Since na-reverse mo na siya, is magiging ang equation mo na to is magiging positive na lang to, magiging addition na lang din siya. Or vector addition. Since na yung second vector is naka-reverse na siya. Okay, how about vector in algebra or multiplication? Vectors may be multiplied by scalars. The magnitude of the vectors changes, but its direction does not when the scalar is positive. Although it reverses direction when multiplied by a negative scalar, multiplication of a vector by a scalar also obeys the associative and distributive law of algebra, then leading to, okay, ganito naman kapag multiplication ng vector algebra. For example, meron kang r plus s na equation, then multiply natin sa a plus b. Okay, sa multiplication kasi is di-distribute lang natin or distributive law of algebra. Kaya mangyayari r times a plus b, okay, dinistribute natin yung r tsaka papunta sa a at tsaka b. Kaya magiging r times a plus b. Then kasunod naman na i-distribute natin is yung s. That will be s times s plus b. Then ang magiging equation na is r times a, kaya magiging ra, ganun sa mga vector algebra. Then plus r times b, okay, we have ra times plus rb. Then yung kasunod naman na equation s times a plus s times b. Okay, ito na yung naging equation niya. Kaya ang nangyayari, mapapansin natin sa mga final answer is naka-vector addition na lagi siya. Katulad dito, may plus, then may plus. Okay, kaya magiging equation sa vector algebra and multiplication is RA plus RB plus SA plus SB. Okay? Yan yung mga example sa vector algebra in the operation of a multiplication. Okay, next. Okay, how about naman sa division ng mga vectors algebra? Okay, division of a vector by a scalar is merely multiplication by the reciprocal of the scalar. Two vectors are said to be equal if their difference is 0 or A. Okay, A equivalent to B if A minus B is equal to 0. Okay, sa division lang kasi is ano lang siya, equal lang din lagi siya sa 0. Kumbaga may summation ng 0. Kumbaga A equals to B, then ilipat mo lang sa kabila to, kaya magiging A minus B equal to 0. Ito na yung magiging vector algebra. Okay, next. Okay, now we have the vector components. To describe a vector in a rectangular coordinate system, let us first consider a vector R extended outward from the origin. Then, a logical way to identify this vector is by giving a three-component vectors. Kasi dati kung two axis lang yung kino-consider natin is meron tayong X na naka-horizontal, then pag sa vertical is Y axis. In this given, we have a three-coordinate axis. Then whose vector sum must be given vector. If the component vectors of the vector R, meron tayong tatlong Cartesian or Cartesian coordinate. We have X, Y, and Z. Then R is equal to X plus Y plus Z. Okay. Pinapakita lang dito yung equation ng R natin is equal daw siya sa X plus Y and Z. Kaya ito na yung naging equation na. Kasi di ba ito yung sa X natin, pag ganito yung X, then sa Y, nakaganito, then usually sa gitna, yung nasa loob kasi is yung ating Z, then ito yung sa R. Para ma-compute natin yung R, ang equation lang na gagamitin natin is, pagpaplasin lang natin tatlong Cartesian, that will be X plus Y plus Z. Okay? That is the example for vector components in rectangular coordinate. Or meron tayo yung tatlong coordinate na X, Y, and Z. Okay, next. Okay, meron tayong mga characteristic or yung parameters na ginagamit sa vectors analysis. Una lang nga dito is yung tinatawag nating unit vector. Okay, ano ba yung unit vector? Pag sinabi natin unit vector is the component vectors have magnitude that depend on the given vector, such as r, but they each have a known and a constant direction. Okay, ibig sabihin, pag unit vector natin is meron tayong component na ng vectors na meron siyang magnitude, then nagde-depend siya kung ang given na vector katulad nito dun sa example is r, but they each have a known and constant direction. Ibig sabihin, meron siyang value na sarili, yung ating vector. Then, meron siyang constant direction. Hindi nagbabago. For example, ax plus ay plus ac, then meron tayong given na Cartesian na ganun. Then, yung a na yun is may value siya, yung constant na lagi siyang nasa x, then sa y, then say, hindi na siya nagbabago bago yung direction. Kung nasa x lang siya, nasa x lang siya. Then kung sa y lang din. Kung nasa say naman, doon lang din siya ang direction, di na nagbabago. Okay, kaya usually, pag sa mga vectors analysis, ina-add na lang natin yung pare-parehas ang direction. Maybe next meeting we'll have an example for that Cartesian addition and multiplication. Okay, next, this suggests the use of unit vectors having a unit magnitude by definition. They are parallel to the coordinates axis and they point in the direction of increasing coordinate values. Okay. Ang unit vectors kasi is meron siyang unit magnitude by definition. Ibig sabihin meron na siyang value. Then they are also parallel to coordinate axis. Pag sinabi nating parallel is meron siyang counterpart katulad ng ax or 3x, meron siyang counterpart sa ibang axis. Kung sa y naman is 5y, ganon. Then pag sa say naman is, for example, meron siyang 6x. Okay? That is parallel to a coordinate axis and they point in the direction of increasing coordinate values. Okay, that is the unit vector. We reserve the symbol for unit vectors and identify its direction by appropriate subscript. Then, thus, ito na ang example na sinasabi ko kanina. Meron tayong tatlong coordinates katulad dito. Meron tayong x, y, and z. Thus, ax, ay, and ac are the unit vectors. Okay, ibig sabihin ito yung mga unit vectors example. Ax, ay, and ac. Then, since unit vector siya, pwedeng magkameron ng value yung a. For example, meron kang 3x, then plus 4y, plus 5c. Okay, yan yung mga example ng mga unit vectors in the rectangular coordinate axis. Okay, then they are directed along the x, y, and z axis. Okay, as I said before, yan nga, ang direction niya is along sa x, y, and z axis. Okay, ganito yung graph ng x. Okay, ito yung sa x, then ito yung sa y, then ito yung sa z, then ito yung sa r natin. Okay? Or vector r's. Then para ma-compute lang yung vector r's equals to x plus y plus z. Okay, tapos na tayo dito. Okay, now, we will explain now the vector field. Okay, what is the vector field? Vector field is a vector function of a position vector. In general, the magnitude and the direction of the function will change as we move throughout the region. And the value of the vector function must be determined using the coordinate values of the point in equation. Okay, pag sinabi nating vector field, ito nga yung vector function of a position vector. Kumbaga meron siyang position. Then, in general, pinagsama lang natin siya. Meron siyang magnitude. Then, meron din siyang direction of the function. Will change as we move throughout the region. And the value of the vector function must be determined using the coordinate values of the point in the question. Okay, that is a vector field. Because we have considered only the rectangular coordinate, pag sinabi natin rectangular coordinate, meron tayong x, y, and z. We expect the vector to be a function of the variable x, y, and z. Okay, that is the vector field. Okay, next, we have the circular cylindrical coordinates. Okay, ano naman yung circular cylindrical coordinates? The circular cylindrical coordinate system is the three-dimensional version of the polar coordinates of analytic geometry. In polar coordinates, a point is located in a plane by giving both its distance p from the origin and the angle between the line from the point to the origin and arbitrary radial line. Okay, sa circular cylindrical coordinates is kung sa rectangular coordinates is meron tayong x, y, and z. Dito naman is meron tayong distance p from the origin tsaka angle. Ibig sabihin, meron tayong distance p dito, then meron din tayong angle, combination ng dalawa. Kung familiar kayo sa mga algebra na ginagamit nyo sa advanced mathematics, meron tayong dalawang doon ginagamit, yung polar, that is yung r, tsaka yung angle. Ganito rin yun. Yung r naman dito is yung distance p, then yung niyan sa polar niya na angle, ito yung angle between the line from the point to the origin. Okay, that is the example of polar coordinates. Then this polar coordinates is ginagamit natin to sa sa circular cylindrical coordinates. Kasi three-dimensional version din siya ng polar coordinates ng analytic geometry. Okay? Okay, yun nga, as I said before, in a polar coordinates, a point is located in a plane by giving both its distance p from the origin and the angle between the line from the point to the origin and an arbitrary radial line taken as theta equivalent to 0.4 in circular. Okay? In circular cylindrical coordinates, we also specify the distance A. Okay, meron din tayong distance A doon ang ginagamit of the point from arbitrary. Usually, sa susunod na lecture natin, magkakaroon tayo example dyan. Usually, yung distance A natin of the point from arbitrary is usually ang say natin is equal to 0 kasi it is the reference plane that is perpendicular to line P equal to 0.